This is the lab on stress and strain. This is always a very quick one. You will see that in the video. It only took us a few minutes to take the measurements. The setup took just another few minutes. I mean, a total of 10-15 minutes or so. It's always a quick one, as I said. This one here is actually this. Besides that, this is the theory part. The curve for the rubber band usually follows this, that as the force increases, which is the weight hanging on the rubber band, that the strain does not keep increasing linearly, but instead the strain actually gets less and less, and therefore you see that steep going up. Turns out when you look at the data that is applied, that's not the case. It's in fact linear for today's data for the rubber band that I used. In fact, here is the rubber band. That's how it's usually done. I did a little bit different. I don't think that was the reason. It must have been the rubber band. In fact, it snapped before I showed that behavior, I think. This experiment, by the way, with steel wire, you're not going to do that, and I didn't do it either. All right, so which means skip table 1 and only do table 2, for which you need the Excel sheet. Again, I put the measurements here in kind of italics, or this font that looks like it's handwritten, and of course these numbers for the mass are 100, 200, 500, 600, 700, and so on, and we just wrote these in. These I did with a caliper just before we started filming, so the width, thickness, and length, you see them here. You also have to insert them into the Excel sheet. So let me actually show the video of the experiment, and then I'm going to show the analysis with the Excel sheet. Now, hopefully, here it is. Yes, is there actually a light that tells me it's recording? Okay, so I put a couple of rubber bands here. We measured the thickness, original length, and width before, and I put a couple there because they seem to rip easily, even though they're nice, they look nice. So here it is. I put an original 50-gram hanger on there with another 50 grams to make it the original 100 grams. And so my first length is 160 millimeters. Then I'm going to put on 100 grams. And I measure 180 millimeters. For 300 grams, 210. For 400 grams, 240. 500 grams, 280. For a total of 600 grams, 320. Are we at 700 now?
Yeah.
Reza is doing this with me. 360 millimeters at 800 grams. 400 millimeters at 900. 440 millimeters. Are we at 1,000 grams now?
No, yeah.
All right. 470 millimeters. Okay, now I have to be careful because I don't know if it's going to rip. By the way, I do have a counterweight over there. This is, of course, a torque, so I have a torque here, and I have to have a counter torque there. Let's see, that looks like 510 millimeters. 540. 570. It looks pretty linear, right, Reza?
That seems like to me.
It usually looks...
If you go a little bit down, probably going to be
600. And 630. 660. And technically I would actually continue after that, but I think that's going to be my last one here. And it certainly looks linear. Usually we get kind of like an interesting polynomial curve out of this, but this one here is 700. I do one more, and then maybe it rips. Yes, it did. There you go. All right. That was a good finish. All right. So here's the Excel sheet, and let me just show you what to do with the data. So the original length was, actually that wasn't 18 millimeters, that's 180 millimeters. I have to fix that. It was 18 centimeters. And then the width was 3.0 millimeters. That's actually true. And the original thickness was, actually it was 1.3, but I used 2 rubber bands, so it's a total of 2.6 millimeters. And then it calculates the original volume right away. I'm going to take these numbers out here. I'm going to be careful to leave the first line. So here I have the first length that I measured for 100 grams. I measured 160 millimeters. And notice that everything else here is calculated. Okay, that negative 20 there looks a little odd, but what happened was that it was wrapped around, so the total length was 180 millimeters, but when it hung down as a triangle, that was really only 160. All right, I had to think there for a moment why that is. So then I fill in 180 here, 210, 240, and then I'll let you fill in the rest. And here's what you actually do with the data. Highlight this one here and notice the formula is already there, so don't do anything with that, otherwise you have to start over again. And then you grab this little corner here and pull it down, and it calculates the weight for each of these masses over here. You can do the same thing here, so the change of length is then negative 20, 0, 30, 60, and so on. And then you can also do it all at once, so highlight everything here and then pull it down. And yeah, I realized, ooh, that didn't work out very well, so let's take that one out. Actually, it still seems to be graphing, so I think I'll just leave it in there. Let's see, it divides by 0 here. Anyway, and that's really all it is. Very quick experiment. Very quickly put in the data into this Excel sheet, and that in as well. No conclusion for this experiment.